Well, in previous video we have seen the introduction part of electromagnetic wave. Electromagnetic wave is the combination of oscillating electric field and magnetic field. So here the electric field is propagating along z-axis, whereas the magnetic field is also propagating along z-axis, but the direction of amplitude of electric field is along y-axis, so it is AY cap, and the direction of amplitude of magnetic field is along x-axis, hence mathematically we used to represent it as AX cap. So mathematically in general we used to write the electric field E is equal to E naught cos of omega t minus beta z AY cap. This minus beta z, minus indicates the wave is propagating along positive direction. If I write omega t plus beta z, then the wave propagates in opposite direction. So E naught represents the magnitude maximum peak, and it is a harmonic function, hence we can take cos as well as sine, and omega represents the frequency of the wave, and the beta represents the phase constant. So this is the equation in free space. In free space there is no disturbance, so there will be no attenuation. So if the wave propagating through a medium, then the equation E is equal to E naught e power minus alpha z. This minus alpha z indicates the decrease in amplitude. If the wave propagates in a medium, then the amplitude of the wave keeps on decreasing, and it is exponentially decreasing, hence we used to write it as e power minus, and alpha denotes the attenuation constant which depends on the medium. So that is about the introduction. Now we shall move on to the topic wave equation of E and H in free space. In free space, as we people know, the charge is equal to 0. If charge Q is equal to 0, then charge density rho is equal to 0. And if charge is equal to 0, obviously I is equal to 0, current is equal to 0. If current is equal to 0, therefore the current density J is also 0. Now I am going to derive the wave equation of E. Wave equation of E can be derived by using Maxwell equations. So these are all the 4 Maxwell equations, and which is very important because which explains the complete electromagnetics. It is not that Maxwell discovered those equations. These equations discovered by actually Gauss, Faraday and Ampere, but Maxwell worked on these equations and explained that these are the 4 equations on which complete electromagnetics is based. So for Maxwell first equation states that divergence of D is equal to rho. The Maxwell second equation, and this is derived from Gauss law. The Maxwell second equation states that divergence of B is equal to 0, and again it is derived from Gauss law of magnetostatics. And the Gauss law third equation states that curl of E is equal to minus dou by dou t of B vector, and Maxwell fourth equation states that curl of H is equal to J, where J is the current density, plus dou D vector divided by dou T. The derivations is not there because it is not that Maxwell discovered. It is discovered by actually Gauss, Faraday and Ampere. So based on this equation, we can derive the wave equation of E as well as H in free space. So this is a condition. In free space, Q is equal to 0, rho is equal to 0, I is equal to 0 and J is equal to 0. So now I am going to derive the wave equation of E from Maxwell third equation. Please make a note of these 4 equations. So from these 4 equations I am going to derive. So from Maxwell third equation, curl of E is equal to minus dou by dou t of B. Therefore curl of E is equal to minus mu dou by dou t of h, because as we know d is equal to epsilon E and B is equal to mu H, where D is the electric flux density, B is the magnetic flux density. So taking curl on both sides, del cross E, I am going to take the curl on both sides, LHS as well as RHS, is equal to minus mu is a constant, dou by dou t of curl of H. Consider this as equation number 1. I will take LHS first. Del cross E is equal to, from vector identity, this is a rule, the curl of E is equal to divergence of E into del minus del dot del into E. So from Maxwell first equation, del dot D is equal to 0. Therefore del dot D is nothing but epsilon E is equal to 0. So epsilon is a constant, so del dot E is equal to 0. Therefore del dot E is equal to 0. So from vector identity this is 0. So 0 minus del square E. Now we will take RHS. Minus mu dou by dou t curl of H. So from Maxwell fourth equation, curl of H is equal to J plus dou by dou t of D. So J is equal to 0 because the wave is propagating in free space. So curl of H is equal to epsilon dou by dou t of E, because D is nothing but epsilon E, epsilon is constant. So take this equation as 2. We'll consider this as equation 3. So from equation 2 and 3, we can write equation number 1. Curl of E is equal to minus del square E so minus del square E is equal to, what is RHS here in equation number 1, minus mu dou by dou t of epsilon dou by dou t E, because del cross H is nothing but dou by dou t of E, so that I have replaced it here. So minus del square E is equal to minus mu, epsilon is constant, del square by dou square divided by dou t square E. So minus minus gets cancelled. So del square E minus mu naught epsilon naught dou square E divided by dou t square is equal to 0. This is the wave equation of electric field in free space. Please make a note of it.